Here we have a discrete time, linear time invariant system with a simple block diagram where the input is added to a delayed version of the input, and the question is asking for the transfer function, h of z. So first of all, let's follow x through the system. So we have at this point in the block diagram, we have a delay z to the minus 1 multiplied by x of z. And that's added to x of z. So here we have x of z. So y of z is simply the sum of x of z plus z to the minus 1 times x of z. So we can write that here. Then what we need to do is rearrange that so that we have y of z divided by x of z. So we could take x as a common factor on the right, and then we can divide both sides by x of z, so h of z equals y of z divided by x of z, which looks like 1 plus z to the minus 1. So that there is our transfer function. So the question goes on to ask for a difference equation. So a difference equation is, we could get that directly from the block diagram, or we could get it from the expression there by simply taking the inverse z transform of each of these terms. So the simplest form of the difference equation would be y of n equals x of n plus x of n minus 1, because a delay by one sample, that's what z to the minus 1 achieves. It achieves a delay by one sample. So that's your difference equation. Part B gives a different block diagram and asks for the same. It asks for the transfer function. So we need to do the same. We need to follow x of z through the block diagram. So it looks like there's quite a lot going on. I'm going to call this point here, I'm going to call that P of z, so that I know at this point here I have a delayed version of P of z, so z to the minus 1 times P of z, and at this point here I have a further delayed version, so it's z to the minus 2 times P of z. And I can then say that because that gets multiplied by minus 5 over 3, and this gets multiplied by 5 over 3, and then they're added together in this block here. So I can say y of z is equal to z, or let's take P of z as a common factor. So it's P of z times minus 5 over 3 z to the minus 1 plus 5 over 3 z to the power minus 2. So now we need to look at the left side of the block diagram and say, what is it that we actually have at P of Z? So it looks like P of Z has minus 2 over 9 times Z to the minus 2 P of Z, added to Z to the minus 1 P of Z, added to X of Z. All of these add up to give us P of Z. So P of Z looks like it's going to be, let me write it up here. P of Z is X of Z plus Z to the minus 1 times P of Z minus 2 over 9 Z to the minus 2 P of Z. So I can probably take P as a common factor, or move P to the left and then take it as a common factor. So I can say P of Z times 1 minus Z to the minus 1 plus 2 Z to the minus 2 equals X of Z. And then divide to find P of Z. So P of Z equals X of Z divided by 1 minus. And I can then take this expression and put it in there where we said Y of Z is related to P of Z. So I can now say Y of Z equals, and I'll take this expression as it is, and I'm going to multiply that by minus 5 over 3 Z to the minus 1 plus 5 over 3 Z to the minus 2. And then multiply that by X of Z. No, sorry, I already have X of Z, so yeah, it's already multiplied by X of Z there. So I can now find the transfer function H of Z by dividing Y of Z by X of Z, and that simply gives me minus 5 over 3 Z to the minus 1 plus 5 over 3 Z to the minus 2 divided by 1 minus 1 plus 2 over 9 Z to the minus 2. So that is our transfer function. So we found the transfer function. It's just not very nice. So I'm going to simplify this. I think I can take 5/3 as a common factor for the numerator, and if I multiply the numerator and denominator by Z squared over Z squared, I then get 1 minus Z in the numerator, and Z squared minus Z plus 2 over 9 in the denominator. And that's much nicer. I think we can do even better. We can factorize the denominator. So I think I can write that as 5 over 3 times 1 minus z divided by z minus a third times z minus 2/3. Yeah, and that looks right. So that is now my transfer function. So I will write that as h of z. That looks much nicer, and that's the best way to answer that. You could probably leave it in the previous form, but this is a much nicer way. Now, whenever you provide a transfer function, you need to provide a region of convergence. So in this case, our region of convergence will be the modulus of z has to be greater than the greater of the two, 1/3 or 2/3. So it'll be greater than, where the two regions overlap, it'll be greater than 2/3. Now the question goes on to ask for the step response. The step response is simply the output. So let me write it like this. S of n is the output y of n when x of n happens to be a unit step, u of n. So if the input is a step, then the output is called the step response. So the question is, what is y of n? Now, to find that, we would start with the z transform of the unit step. Or another way to say that is, we would say what we want is y of z when x of z is the z transform of u of n. So x of z, y of z equals, by definition, the input multiplied by the transfer function. Now the input is this, z over z minus 1, because the input in the time domain is a unit step. So we can simply say y of z is equal to z over z minus 1 multiplied by the transfer function h of z, which we just found in the previous section. So the transfer function is this expression here. So we can copy that and multiply it here, and that's going to be our y of z. So if only we could find the inverse z transform of y of z, if we could somehow find y of n, then that would be our step response. But it's not easy finding the inverse z transform of something with so many z's in the denominator. So we're going to need to simplify that. That's probably going to involve partial fractions. So let's see if we can simplify this at all. It looks like, if you look carefully, we can cancel that with that if we introduce a negative sign. So that makes life a little bit easier. We can write y of z, and in particular, if we if we divide by z, we get y of z divided by z is negative 5 over 3 divided by z minus 1 over 3 times z minus 2 over 3. And we would like that to look more like something over z minus 1 over 3 plus something else over z minus 2. And that's where your partial fractions comes in. So you can write your expression. It'll look something like this. A times z minus 2/3 plus b times z minus 1/3 equals minus 5 over 3. So equal to the numerator here. And we can then set z equals 1 over 3. That will give me a times 3 equals negative 5 over 3. So a is equal to 5. That's good. I can then set z equal to 2/3, and that will give me b times 1/3 equals minus 5 over 3 equal to negative 5. And that too is helpful, because now we can write y of z as two fractions. So I can say y of z is equal to a, which is 5, times z over z minus 1 over 3. I say times z because what we found was y of z over z. We had initially divided by z. Then minus 5z over z minus 2/3. And now we can use the table of inverse z transforms to find y of n, the time domain. So y of n looks like it's going to be a to the power n u of n. So in this case, a is going to be 1/3. So it's 5 times 1/3 to the power n u of n minus n 2 over 3 to the power n u of n. And that's your final answer, unless you want to tidy it up. I think I will. If I take 5 as a common factor and u of n as a common factor, I can probably take 3 to the power n as a common denominator as well. So it's something like 1 to the power n minus 2 to the power n divided by 3 to the power n. And 1 to the power n is simply one. So it's just 1 minus 2 to the power n over 3 to the power n, all multiplied by 5 unit steps. And that's your final answer. I think that's the neatest it'll look. So that's your step response. And really what we should call this is not y of n, but s of n. Because the question was, find the step response. So the step response is s of n. Now the question then goes on to say, what would the output be if the input was some exponential function? So again, what they're saying is that find y of n if x of n is that. So it would help if we could find that in the z domain if x of z were the z transform of that, which using the table would be simply z over z minus a half. And as we said earlier, y of z, by definition almost, is x of z multiplied by h of z. X of z is z minus 1 over 2. So it's very similar to what we just did. I'm going to multiply by the expression we found earlier for h of z. But this time, the 1 minus z doesn't seem to cancel. So we're going to need partial fractions again. But let me get rid of 5 over 3 and the z, just to make it easier to work with the fractions. So y of z over z times 3/5 equal to 1 minus z divided by z minus a half, z minus a third, z minus 2/3. And what we want is that to look something like this. What we want to do is to find A, B, and C. And once again, this is a case of partial fractions. So you write out your equation and you substitute values for z and you find the constants A, B, and C. So I've already done that. And the answer looks like this. Negative 18, 12, and 6. So because that's 3/5 times y of z over z, we can write y of z equals, and then we multiply each of these by 5/3. So y of z is equal to negative 6 over 5z divided by z minus a half plus 4 over 5z divided by z minus a third plus 2 over 5z divided by z minus 2/3. Now, again, we need to consider the region of convergence here. So the region of convergence is the modulus of z is greater than the greatest of these three. That's where the regions will overlap. So the greatest of the three seems to be 2/3. So now what we're after is the output, y of n, because the question says, find the output when the input is such and such. So we need to find y of n. So what we need to do is to find the inverse Laplace transform of each of these. So first one is simply y of n. Then you've got minus 6 over 5 times half to the power n times u of n plus 4 over 5 a third to the power n u of n, and the last term is 2 over 5 2/3 to the power n u of n. So it's simply using the table, and each of these values for a, so it's z minus a, each of these values for a gets put in there. Now we could simplify that. We could take 1 over 5 as a common factor, we could take a common denominator, or we could even take the unit step as a common factor, but I think that's good enough. That's the final answer for y of n. So the question was, find the output when the input x of n equals a half to the power n. That is your final answer.